In this video, we're going to look at the combination of transformations of a graph of a function. So what do we do if we have f of 2x minus 3? We know if we put a number in front of x in the function notation that it represents a stretch parallel to the x-axis, and the scale factor of that stretch will be 1/2. And we know if we take a number from this, then this will be a translation 3/0. The question is, which do we do first? Do we do the translation first, or do we do the stretch first? Okay, so this is the form f qx minus h. So here we've got a function, f of x is x squared minus 2x minus 1. Okay, and I'm going to do a clicked. So the red one here, we can see the image which will move. So if I did the translation first, so if I move this h, so h is 3 units. Okay, so that's now f of x minus h, and then did the stretch, which is 2. So let's move this to 2. This is the final image of f of 2x minus 3. Okay. Now, we're going to look at this in two ways. If we just click here we did the translation first. So we moved the green graph to the orange graph, and then what we did is we did a stretch scale factor 1/2. So this point here will go halfway. This point here is like 2, and then it will go halfway. So we can see we've just stretched everything. This point here is actually 6 away, and therefore on the image it goes 3 away. So you can see we have done the stretch scale factor 1/2. So this is what we've done in number 1 in here. So we've done f of qx minus h, which is f of 2x minus 3. If we substitute it in, we get f of 2x minus 3 all squared minus 2 times 2x minus 3 minus 1. And if we simplify that algebraically, we get this graph here, which is 4x squared minus 16x plus 4, which is the red graph here, which we translated first, and then we did the stretch scale factor 1/2 parallel to the x-axis. So translation h0, 3/0, followed by a stretch scale factor parallel to the x-axis 1/q, which is 0.5, will give us the resulting graph. And you can think of it as this way. If I had to solve an equation like 2x minus 3 is equal to some number, you would add 3 first, i.e. you would do the translation, and then you would divide by 2 in order to get to the answer. The divided by 2 represents the stretch. Now that's one way of looking at the problem. However, there is another way of looking at the same problem and doing the transformations in slightly different order. So let's have a look at that. So we'll just get rid of this for a moment. And this, by the way, this app I'll put in the notes of the video so you can try it for yourself. So we'll get that, and we will now put h back to 0, and we'll put q back to 1. So we just click, there is my original graph. Okay, in this one we're going to do something slightly different. What we're going to do is we're going to take q out of the bracket, but keep it inside the function sign. And if we do that, the function becomes f of q of x minus h over q. So if you multiply that back in, you're going to get qx, and if you multiply that back in, you're going to get q over q, x minus h. So you're going to get back to this f of q x minus h, which you can do. But if you do this, then the transformations happen in a different order. You will move this 2 like that, and that will give this one here, which I've just put onto it. So that represents a stretch parallel to the x-axis scale factor 1/2. We can just check that with a few points. You can see that the minimum point here has gone to here. We can't actually see the coordinates, but we can see that it's exactly halfway. Let's take another convenient point. This point here is quite convenient. This is 3 away, so it now goes 1.5 away. On this side, it is 1 away. It now goes half the way. Going further up the graph, this is 4 away. It goes to 2. This is 2 away from the y-axis, so it goes to 1. So we can see definitely there we've done the stretch. But if we now move h, okay, it's not moving according to h, so h had to be equal to 3, remember? Okay, and we've got back the other way. But what we've done is we've actually done a translation half of the value of 3. In fact, what we have done, we've done a translation 3 over 2. So that was q, and that was h, and that was p. So the translation becomes h over q. And if we do it that way, we first do a stretch parallel to the x-axis, scale factor 1 over q, followed by a translation h over q, 0. So what's happened, it has now been moved. So from the blue graph, you can see that this is at 0.5, and now it's gone 1.5 to 2. So every point has moved 1.5 units along. Same here. We can see this here. This is at 1 here, so it goes to 2.5 here. And so the stretch graph has been translated 1.50, so 1.5 in units in the positive direction. And doing it this way, it looks like this. So we do f of q. You take the q out, so it becomes f of q. But notice the q still in the function. In the function, so q x minus h over q, which is f of 2 in this case, of x over 3 over 2, and then you'd have to substitute 2x minus 3 over 2 all squared minus 2 times 2x minus 3 over 2 minus 1, which if you work out would give that. Okay, it's slightly more difficult algebraically. So if you're going to do it that way, you have to think of it as a stretch parallel to the x-axis, scale factor 1 over q. 1/2 is equal to 0.5, followed by a translation h over q, 0, which is 3 over 2, 0 in this case. Now, so there's two ways of looking at the same problem. The only thing is you've got to remember that the translation in this one is going to be 3 over 2, 0. Okay, and in this case you do the stretch first, followed by the translation with a different value, h over q. But here you do the translation followed by the stretch. Okay, in some ways this one would be easier to actually see, because if you think of the equation idea like I mentioned before, you add 3, divide by 2 seems to be the right thing. So adding 3, translation, dividing by 2 is the stretch in this case. So adding h first and then dividing by q. So this way, because the q is outside, you would have to do that first, and then you'd have to do this translation. Okay, you can decide which way you want to do it, and there are cases where this is actually an easier way to do it than this way. Okay, but this is just the general idea. I hope you've understood. Like I said, I will put the GeoGebra app inside the notes of this video, so I hope you've enjoyed this video, and I thank you very much for watching, and I hope you've understood.